So to pick back up where we left off with group problem number 1, now we want to find the angle of our vector from the cell tower down to Edmond North. We set up our expression, the inverse tangent of 2.3 divided by 3.4. We'll go ahead and plug that value in. We'll get about 34.1 degrees, rounding to 3 significant figures. Now, if we get an answer like this, we have to think, am I actually traveling at 34.1 degrees? Well, no, I'm not really traveling at that angle because I'm moving southwest, which means I'm in quadrant number, we think about this, quadrant 3. So I'm actually moving in a direction like this. I'm southwest, not southeast. This 34.1 degrees is really based off of, well, 180 right here. So I'm just going to add to 180. So 180 and 34.1 gives me an angle of 214.1 degrees, which means I'm moving down to the left, or quadrant 3, southwest. So my final answer here for part C, the displacement from the cell tower all the way down to north, would be 4.10 miles at 214.1 degrees, which is the answer that we are looking for. So now we're going to use those same skills in solving the rest of our group problem. So we'll come to the backside or part D. Now here, we want to go from north out to Lake Arcadia. So we're just going to follow the instructions that we're given. So from north, we'll just choose a point. We'll travel 2.4 miles east. And then our instructions tell us 2 miles south. And then 3 miles east. And then finally 0.1 miles south. And they don't have to be perfectly to scale, just giving us a good idea of what we're doing. Now, just as before, we want to group together our similar components. In the x direction, or the east and west horizontal direction, we're moving 2.4 miles and then 3 miles both east, which means we can add those together for a total of 5.4 miles east. The y direction, we're moving south in both components, 2 miles and 0.1. So we'll add those together for a total of 2.1 miles south. We can also call this negative 2.1 miles. Because of our sign convention, going down vertically, we usually represent as negative. Either one is appropriate. So now I'm going to take these and redraw a new picture. I'm going to come to a new page, so we have a little bit more space. We'll draw a vector that is 5.4 miles east, or positive 5.4 miles in the x direction, and 2.1 miles south, or negative 2.1 miles in the y direction. And then we will draw our overall displacement. Remember, this is from north down to our spot at Lake Arcadia. So now that we have our overall displacement vector drawn, now we can use our components to find the total. Because we have a right triangle here, we can use Pythagorean theorem just as before. A squared plus b squared equals c squared. So we'll take 5.4, plug that in for a. It doesn't really matter here which side we call a and b. And then 2.1 for b. Remember, even if you refer to that 2.1 as negative, when we square that, it will then become positive. So 5.4 squared plus 2.1 squared is equal to c squared, which is 33.57. And finally, to get c by itself, we'll then take a square root. So then we'll square root our value here, 33.57. We get approximately 5.79. So our magnitude, our hypotenuse effectively, is 5.79 miles. Now we also want to find the other part of our answer, which would be a direction. So I will use a trig function here to find our angle. And we want to base our angle off of where we start, from north to Lake Arcadia. So I'll use a trig function here. My default is to go with tangent. So we'll take tangent of theta. Remember, tangent is opposite over adjacent. Opposite is directly across from our angle, 2.1, divided by adjacent, which is the side touching that's not our hypotenuse. So 2.1 divided by 5.4. Then to get theta by itself, we need to get rid of the tangent attached to it. So we'll multiply by inverse tangent on both sides of our equation here. tangent multiplied by inverse tangent, those will cancel out. And we'll be left with an expression for just theta. Theta is equal to the inverse tangent, of 2.1 divided by 5.4. So now we'll plug this in. Second tangent, 2.1 divided by 5.4. We get a value for our angle, theta, which is 21.3 degrees. Now again, we have to be thoughtful. Are we actually moving at an angle of 21.3 degrees? Well, no, we're not measuring that directly from zero. Our angles have to be measured relative to zero. So if we come back to our picture here, now, I'll erase this part. We're actually traveling from north to Lake Arcadia, south and east, right? Maybe we went 5.4 miles east, 2.1 south. So the angle here, forget that this even exists for right now, this angle here is 21.3 degrees, and that is 21.3 degrees down from 360. So we'll take 360 minus 21.3. We end up getting about 338.7. We can call that 339 degrees. You can also, if you wanted to, just call that negative 21.3, since it's 21.3 degrees and down from zero, or clockwise from zero. So now our final answer for part D, from from north, out to the lake, is our magnitude, 5.79 miles, at our angle, 339 degrees, which is quadrant 4, approximately. We are down and to the right. Now the last part of our problem is going to involve putting everything together to get from the cell tower all the way down to the lake. This value here doesn't actually tell us if we get signal at the lake, because the signal's not coming from north, it's coming from the cell tower. And that's what we need to figure out. I'm going to pause for a moment and make sure the video is still working. Okay, we're good there. So now we're going to come back to our last part, part E. Here, it says that we want to travel from the cell tower to north and down to Lake Arcadia. To find how far we are, we only need to find the total displacement vector. Draw a picture, add the vectors we found in C and D, and we must add those using the rules of adding vectors. So what I'm going to do here is I'm going to redraw the entire picture from the tower all the way down to Lake Arcadia, right? So I'll use my instructions. From the tower to Lake Arcadia, we start by going to north. So 1.3 miles south, and then 2 miles west, 1 mile south, and then 1.4 miles west. Okay, and that will end us at the north. Now the next thing we need to do is to go from north down to Lake Arcadia. So there we travel, we can even use our steps from above, 2.4 miles east, do these in a different color, and then 2 miles south, 3 miles east. That's probably not the straightest line in the world, sorry about that. And then 0.1 miles south. Now again, picture's not drawn to scale, just giving us a rough idea. And this will end us down at the lake. So to get from the tower down to Lake Arcadia, we could travel all these different steps to get there. However, we want to know the displacement, the straight line from the tower down to the lake. We want to know this vector. How do we get there? Well, we have to add these vectors, meaning we add the components or the similar parts. So now I'm going to look at what's going on in the x direction here, or the horizontal direction. I travel 2 miles west, 1.4 miles west. So overall I go 3.4 miles west. I could also call that negative, right? And then 2.4 miles east and 3 miles east, which gives me 5.4 miles east, which we could also call positive. It's to the right. So negative 3.4, 5.4 gives me a total of 2 miles, which would be positive, which means we travel further in the east direction overall. Now we're going to do the same thing for the y direction. But as you should notice, all the y direction vectors, the y components, are all going directly south. So we don't have to add or subtract any components here. We can just add them all together. 1.3 and 1 gives us 2.3. 2.3 and 2 gives us 4.3. Add 0.1, we get an overall value of 4.4 miles south. You can call that negative if you want to, but we can just say it's south. It gives us the same information. So now I'm going to take these vectors, the overall x and y components, and I'm going to draw one final picture from the cell tower all the way down to a lake. That would be, what was it, 2 miles east, I believe. Double check, there we go. And then 4.4 miles south. This will get us from the tower down to Lake Arcadia. And lastly, we will find our overall displacement. So again, just like before, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Here we go. Does not matter which side we call A and B, C will always be our hypotenuse, our longest side. So A, let's say, is 2 miles squared. B, we'll say, is 4.4 miles. Again, we can call that negative as well. But when we square that value, it will become a positive. So 2 squared plus 4.4 squared gives us 23.36 is equal to c squared. And then we take a square root to get c by itself. So the square root of that value, 23.36, gives us a value c that is 4.83. Now right there, that should tell us we're within range, right? We're underneath 5 miles, or shorter than 5 miles. We do want to go ahead and find our angle. It's good practice when we're dealing with vectors to find a magnitude and a direction. We want to find that direction relative to our starting point. Now we should know that we're going south and east, which means we should be somewhere between 270 and 360 degrees. So I will here use a tangent function. So tangent of our angle theta is equal to opposite of our angle. Opposite or across is 4.4 divided by adjacent, which is 2. And just like before, to get theta by itself, we'll multiply by an inverse. Multiply by an inverse. So tangent and inverse tangent, that will give us theta by itself, which is equal to the inverse tangent of 4.4 divided by 2. We'll plug this in. Second tangent, 4.4 divided by 2, gives us a theta, an angle of about 65.6 degrees. Now again, as we said before, our angle should actually be in quadrant 4, somewhere between 270 and 360, because we're traveling south and east here. So, to put that in context, think this way. We're traveling south and east. We found that our angle is 65.6 degrees down, okay, from the horizontal, which means we can subtract from 360. So 360 minus 65.6 degrees. Here we go. We should get about 294.4, which we can just round to 294 degrees. So now that we found our angle, we can put that together for our final answer. So from the cell tower all the way down to Lake Arcadia, we have a displacement of 4.83 miles, which is good, we're within range, at an angle of 294 degrees. And that is how we would present our final answer, right? So we do get a signal at the north, and we do get a signal at the lake based on the information that we are given. Okay, so remember, when we do go through this process of adding vectors, think about our steps. Drawing a picture, breaking our vectors into components. Here they were already given to us in component form. Adding the similar components, and then redrawing our final picture and solving using Pythagorean theorem and a trig function. Okay? We cannot just solve these by adding magnitudes and adding angles. We can only solve this by using the process that we've been learning. Okay? If you do have questions, do not hesitate to ask. Hopefully this gives you an idea of what we covered in group problem number 1. Good luck.